Hi, welcome to another video on linear algebra. So today we're going to be going over 1.6, which is basically a continuation of 1.5, where we're going to be going over linear systems and invertible matrices and getting more practice on doing the inverse matrix algorithm. So one thing to recall is this sort of small proof. A times x is equal to b. Well, if you multiply the inverse matrix of A to both sides, you end up with x is equal to A inverse times B. And that'll basically get you the x values. So let's go ahead and try that using this problem. So we're going to make this simple. And we're going to say that these constants are going to be basically the b. Right? Okay, so let's set up our augmented matrix. So we have 1, 1, 1, 1, 1, negative 4, negative 4, 1, and 1. And I'm getting these values from the coefficients of the x and y and z, right? So that's the x, that's the y, and that's the z, if you can see that. Okay, so then I'm going to write the identity matrix. Okay, so this on the left is my A matrix, and then on the right is my identity matrix, which is the 3 by 3. And we're going to go ahead and work on that inverse matrix algorithm. So basically we're going to find A inverse. And I'm going to go ahead and write this x equals A inverse times B. So what we're going to do with this is we're going to find our A inverse by doing the algorithm. Then we're going to plug it in here to this A inverse. And we're going to plug in our B values. And we're going to multiply them and get our X matrix. Okay, so let's go ahead and do that. So let's first operate on this by doing two operations at the same time. R1 times negative 1 plus R2, that's gonna produce our new R2. And we can also do R1 times 4 plus R3, which is gonna give us our new R3. And when we do two operations at the same time, we do the top one first, and then we do the second one, the one on the bottom. And so what we're going to do with this top one is we're going to multiply the entire R1 by negative 1, and we're going to add it to row 2, and that's going to get us a new row 2. The R1 doesn't change, so it's going to stay the same. What's going to change is R2. And then we're going to apply this. So whatever we get here for that top one, we're going to apply this bottom one, which is multiplying R1 by 4, and then adding it to row 3. And that's going to give us a new row 3. Notice, just by like some looking ahead, if you multiply row 1 by negative 1 and add it to row 2, the row 2 will be 0 here on the second row, right? So that is our goal, is to make this a 0 and this a 0. And in this second operation, we're making row 1 4, and we're going to add it to row 3, making a new row 3, which is 0, right? So enough of me talking. Let's go ahead and write that new matrix down. That's going to produce 1, 1, 1, 1, 0, 0. I just went straight across. So, and then it's going to be 0, 0, negative 5, negative 1, 1, 0. And straight across again, that's 0, 5, 5, 4, 0, 1. Okay, so that's what we get when we do those two operations. Now we have the first column. Looks like 1, 0, 0. So boom, that first column is done. And now we have to work on this second column, which is the Y column, if you will. That's the if I'm looking at this, I might say that I can multiply this third row by a fifth, and that'll make this a 1, this a 1, a 4 over 5, which is totally okay. But the point is to make this the identity matrix. So let's go ahead and do another operation. Let's go ahead and... Okay, so if you go back, notice that this is a 0 right here. And if I multiply by a fifth, this will be a 1. What I can do is I can reverse the order of these rows. So I can make this row on the bottom and this bottom row in the middle. So that way I'll have a 1 here on the top, and I'll have a well, the point was to get the 1 in the middle. So then I'll have a 1 here and a 0 here, which is what I want. So that's what I was thinking. And we'll go ahead and denote that by saying R2, and this double arrow means reverse them. And for R3, we're going to multiply it by a fifth, which is going to produce our new R3. Professors might not like when you say, like, if I do this operation, I'll get a new row equal to row 3. They don't like that. They didn't like that I wrote equals the new row, because it's an operation, it's not an expression. So, yeah, maybe not write that, but just to see what we're making, I think it makes it clearer, especially for me. So that new row, the new augmented matrix is going to look like this. 4/5, 0, 1/5. Wow, I'm totally writing the wrong thing. I was calculating that on the wrong side. That's going to be on the right side. There we go. On the left side, you should see that. So this should be our new matrix after that operation. We'll do another operation. This looks like it's going to be a while. Actually, let's do 2 operations. I could see there's 2. So I could do R2, multiply that by -1, plus R1, and that's going to give me a new R1. And that top one, this top one's going to take away this 1 here and make it a 0, which is what we want. And then we're going to do R3, multiply by -1/5, and that's basically going to give me a new R3. And my new matrix should look like this: 1, 0, 0, and I'll go straight across. 1/5, 0, -1/5. Then I have 0, 1, 1, 4/5, 0, 1/5, and 0, 0, 1, 1/5, negative 1/5, and 0. Okay, so as you can see, it's this one right here that is messing up my identity matrix, so I need to get that into a 0, and then boom, I'll be done. Okay, so one more operation will do it. I'm going to multiply R3 by negative 1, add it to R2, and that's going to be my new R2 matrix. So I'll have 1, 0, 0, 0, 1, 0, 0, 0, 1. My identity matrix is complete, which is great because that's what I wanted. And the A inverse will be this. We changed the second one. That's going to be 3/5. That one's going to be 1/5. 1/5. Oops. Totally messed up that number. 1/5. Another 1/5 here. Negative 1/5 and 0. So be careful. Okay, so now that we're done with that, we have our identity matrix on the left and our A inverse on the right. Perfect. So, what was the point of all that? Well, again, we just wanted to plug this into this formula to find our X matrix. And we can go ahead and do that now. X equals A inverse times B. X is equal to 1/5, 0, 1, negative 1/5, 3/5, 1/5, 1/5, 1/5, negative 1/5, 0, times 5, 10, 0. And 5, 10, and 0 were our constants. Yeah, here we have 5, 10, and 0. So that's our B. And if we multiply that out, again, matrix multiplication, you have to multiply this 1/5 by this 5, and multiply the 0 by the 10, and the negative 1/5 by the 0, and then add them together. And if you do that, you'll get a 1. Because if you see, if I multiply 1/5 by this 5, I get a 1, and plus 0 plus 0, that's a 1. So that's how you do it. And it'll just go down like that. It's 1, 5, negative 1. So that's how you do it. And now we have our X matrix. Alright, so let's go on to a next problem. So this one we're going to solve the linear system together by reducing the appropriate augmented matrix. So we have this we have these systems of these linear systems. And then we have, as you can see, these constants B1, B2, B3. Well, basically it wants you to get your A inverse, and here you have two B's. So you're going to get your A inverse and then find the X values for both of these B's. Okay? So let's just say that's B sub Roman numeral 1, and then we'll have B sub Roman numeral 2, and this is our B Roman numeral 1, and this is our B Roman numeral 2. Alright, so let's see. This is honestly a pretty long one. I actually remember doing this in my lecture class, so this definitely will give you a lot of practice. Let's try it out. Well, the first thing we're going to do is make an augmented matrix. And this with all the coefficients, right? So we'll have -1, 4, 1, 0, 1, -3, 1, 9, -2, 1, I'm sorry, I made a mistake. It's not a 1. It's actually a dotted line. Alright, it's a 0. 8, 4. Oh my gosh, I'm just making so many mistakes. -6. Nope, that's a... There I go, making mistakes. Okay, yeah, definitely be careful. I mean, you're not making mistakes, but I certainly am. Okay. So, let's go ahead and get started. Well, let's see. What do I see first? I may want to switch row 1 and row 2. And I'll have a new row 2. Let's see what that looks like. 1, -1, 6, 9, 4, 4. Okay, that sets me up. Makes the matrix look a little nicer and more manageable. And what I also like to do is I like to foreshadow or like think ahead and see like which operations I might have to do. And right now I'm saying R1 plus R2 is equal to my new R2. Okay, so a little more practice on here. I'm going to multiply. I'm sorry, I'm not multiplying anything. I'm just going to add. So that's great. And I'm going to add R1 to R2, and it's going to give me a new row 2. So if you want to see that step by step, I'll show you right now and then delete it. I'm going to write down these rows. So it's basically like a big operation table. So 1 plus -1 is 0. I'll write down what they are. Row 1 and that's row 2. So row 1 plus row 2 will get me a new row 2. So that's 0. 9 plus 4, 13. -2 plus 1. That's -1. 1 plus 0 is 1. And that's a 1. So that's going to be my new row 2. So I can go ahead and put that here. I have 1, 9, -2, 1, 4. Oops. Okay. And that's 0, 13, -1, 1, 1, and then row 3 back there. 0, -5. Okay. So now it's all up to us to make sure that we don't make any mistakes with signs, because that is important, that we don't mess up, because then I'd be really upset if I did all that work and then messed up. Okay, so So now I'm looking at this first column like we always do, and I see if I multiply this row 1 by -6 and add it to row 3, I'll get a new row 3 that is a 0, and that's exactly what we want. So let's go ahead and do that. Row 1 times -6 plus row 3 is equal to row 3. So the new augmented matrix will look like 1, 0, 0, 9, 13, -13. You're not going to like this, but it's -50. Oh, it's not -13. It's -50. -50, -2, -1, and 4. And then we have 1, 1, -6. And you have 4, 1, -29. Don't be afraid of huge numbers, because as long as you trust the math and you do it column by column, you'll get the right answer. Okay, let's go ahead and go this way. Let's see, row 2. I'll multiply, row 2, I'll multiply by 1 over 13, which will give me a new R2. It's a little hectic, but it's alright. We're going to push through. 9, 1, -50, -2, -1/13, and a 4. My dotted line got in the middle. There we go. And we have a 1, 1/13, -28 over 13, and now where'd that come from? 1/13, -6, 4, 1/13, and -29. Alright, that's it. Okay, so what else do I see? Yeah, I can knock out this -50 by multiplying by 50 to row 2 and adding it to row 3. Yep, that's what I'm going to do. Okay, I'm going to go into the next page. So I'll multiply R2 by 50, add it to row 3. That'll give me a new row 3. And then I see that 9. I'll multiply R2 by -9 plus R1 is equal to R2. I'm sorry, R1. If you want to do this in separate steps, totally fine. Go ahead. You have 1, 0, -17, 13, 0, 1, -1/13, 2. Sorry, that's a 0, 0, 2/13, and a 4/13, 1/13, 28/13. That's a negative. 43/13, 1/13, and a negative 327/13. Again, don't be afraid of the huge numbers. Okay, so row 2, row 3. Okay, so for row 3, next operation, row 3, I want to multiply by 13 halves. And as you can see, that'll change row 3. Here it'll make it a 1, which is very desirable. Equals new row 3. 17/13, 0, 1. Boom, boom, boom. So I feel a sneeze coming on. So you might see that. I know you won't see, but you'll hear that I'm kind of human. So if I sneeze, you'll know I'm not a robot, at least. And this is our augmented matrix after that operation. 327/2, which is getting a little cleaner. And what I could do here, I can multiply row 3 by like 17/13, and then add it there and get a new row 1, which is what I'll do. And then I can get rid of that 1/13 using this row 3 again. So let's do that. Row 3, 17/3 plus row 1 will give me a new row 1. Row 3, I'm out of breath. And it's not because I'm fat or out of shape. It's because there's a lot of numbers. Wow, identity matrix, finally. That's 421. Oh, all right. Done. So your mind is definitely in shape after this. As you can see, on the left side we have our identity matrix 3x3, and on the right side we have our inverse matrix, which is exactly what we wanted. Hold on, recalculating. If I look at this again, yes, we have our identity matrix, but we still have our B terms, which is essentially, because we plugged in our B terms, which basically spit out our X values already. So this is our X1, and this is our X2. That's pretty interesting. That's a 1. (421/2) and negative 25/2 and negative 327/2. Wow, that's pretty powerful. So if we look here, we plugged in the B terms that they gave us, and interestingly enough, it spit out the X values. So these are the X values. So let's go ahead and go on to a next problem. So we want to determine conditions on the B's, if any, in order to guarantee that the linear system is consistent. So we want to use these linear systems. B1, 3x1 minus 2x2 equal to B2. Okay, so we're going to first create an augmented matrix. 6, -4, 3, -2, B1, B2. Alright, so let's go ahead and apply our first operation. we have R1. We could multiply that by 6th, and we will get 1 negative 2/3, 3 negative 2. Okay. Oh, I forgot my b's. That'll be b6, b1 over 6, and b2 by itself. Cool. And then I'm going to go down here. I'm going to apply R1 times negative 3, add that to R2, and it's going to get us our new R2. So that matrix will look like 1 negative 2/3, 0 0, b1 over 6, and negative b1 over 2 plus b2. Okay, so what we're going to do is we're going to use this one. And we're going to pull it over here, and we're going to say negative b1 over 2 plus b2 is equal to 0. And we're going to solve for b2. That's going to be b1 over 2. And our b1, b2 conditions is when b1 is b1 and when b2 is equal to b1 over 2. So that is the conditions that they wanted. And that's basically it for this section. So in the next video, we're going to be talking about special matrices, which are pretty cool, and you'll find these a lot in different courses such as physics. So I hope this was some good extra practice, and I'll see you in the next video.